So I'm sitting here watching the stock go up.
It's good.
Phil, I got Phil Beisel here. He's sitting here congratulating Rivian for a good earnings report yesterday, as good as they are going to get, I guess, or at least for now. They're not losing as much money, and the stock went up.
Yeah. Yeah. Well, I mean, they're in a bit of a holding pattern. I mean, I think the thing to celebrate there is that they're in a good place as a holding pattern waiting for their R2, a larger TAM vehicle,
Right.
um, which should do well in the market, I think. It would be nice if the incentive structure was there more for EVs in general,
Hmm.
be it Tesla, Rivian, or whatever, because I mean, really, we're left with a really small number of holdouts around. In other words, I think Tesla would sell more and Rivian would sell more, frankly, if Ford and General Motors sold more
Right.
AVs.
Right. Oh, yeah.
And we started transitioning a bit quicker in the US. I think we're not, I think looking at some really good charts, uh, we won't transition across 50% of the S curve to about 2035. I mean, it's an inevitable transition from ICE to EV.
Hmm. Uh-huh.
I mean, I would bet any amount of money on it. I have. Um, but seriously, that's a long, that's a very that's a very slow slope S curve for how S curves go.
Yeah,
So
and for those of you who are expecting us to talk about engineering things, believe me, we will.
we'll
And it
get
might
there.
be and it might be the most important engineering conversation you ever heard from Phil. But
Yeah,
just one
maybe.
last thing before we get there, you actually turn out to have your money in Schwab, or
Yes.
a lot of it.
Yeah.
And so you want to tell your story of what
Well,
happened over the last couple of days?
well, I opened my first Schwab account when I was 18 years old.
Okay.
So all my retirement funds are there, and my main brokerage account is there, and all my Tesla stock is there. I have an E-Trade account, but that's for uh, Apple and Rivian stock options and RSUs and so forth. But Schwab has been a comfortable place to keep my money. They're not uh, leading the charge on innovative investment vehicles, but it doesn't matter to me because what do? I buy Tesla stock.
Right.
I mean, I don't need I don't need crazy stuff. So sure enough, last year I gave them a piece of my mind about the 2024 vote, and this year we all heard that they were going to vote down Elon's 2025 comp plan, and anybody that hasn't had their head buried somewhere realized that Schwab came around yesterday and changed their mind. Although they don't couch it that way, fair enough. The outcome is that Schwab went from a no vote to a yes vote, ostensibly on all board recommended uh, items. But I'm not exactly clear on that. But certainly Elon's comp plan, which is the big one,
Right.
and sure enough, I gave a call to my investment advisor there. I rarely talk to that person, probably maybe to complain about these things mostly, and he knew why I was calling. and and I was right in the thick of it where he said, "We'll get back to you with either a direct message or email. We think there's good news coming down, so you'll be pleased." So yes, Schwab has moved. I think Schwab owns about a 0.5% in its ETFs or mutual funds. With I don't hold any of those elements of Tesla stock, but still I am a customer of Schwab and don't wouldn't appreciate them voting against Elon's plan. So therefore, they're going along with it. And while it's not probably the material moving, uh, you know, this
Yeah.
they're the 16th largest shareholder by virtue of these funds
Yes.
in Tesla stock. And while they're not State Street, which is number three, who will be voting against, from what I know,
Hmm.
unless the pressure comes down on them. Yeah, I think State Street has over 3%, almost 3.5% or something of Tesla stock, and they're going to vote. They're going to vote down this package. Um, so so anyway, it was a good Tesla retail shareholders are a force to be reckoned with, and I am certain that other companies wish they had activist shareholders like this to
Yeah.
support the company.
No,
These shareholders support the company and the company's recommendations.
right.
And the institutions are motivated by other potential reasons and are also lazy, frankly.
All right, so
So,
let's turn the corner into the engineering thing, and
mhm.
this will be a nice package to squeeze between last night. I had Brian Wang on, and Brian went into AI I'm sorry, 5, 6, 7, and 8, and what he sees as what each of those new hardware packages is going to provide. So if anybody wants to go back and check that out, we'll put the card up at the end. And then tomorrow, probably tomorrow, it could be Friday, I don't know, I'm going to be traveling. Brian will be doing another story, and that one will be on the chips in space question.
Mm.
And now Google has said they're going to put chips in space. Tesla has
Yep.
said they're going to put
Yep.
chips in space.
Yep.
I'm sorry, SpaceX has said they're going to put anyway, and how important that is going to be to Tesla 2 or 3 or 4 years from now. So wedged in between that would be the practical part, the super practical part, which is the FSD, the actual inference, the actual thing that makes the car drive.
Mhm.
And that would be your story.
Yeah, yeah, yeah.
And so we're going to be talking about FSD 14.2, 3, and 4, or something like that. Anyway,
Well, this,
I'll let you talk.
yeah, sure. Okay. Well, let me share my lovely slides.
Okay, all right.
We'll do that, right?
Sure.
Okay. Should see at some lovely moment my screen. Then I'll put it in share mode.
Looky there.
Oops, didn't
You're
do that
getting
right.
you're
Didn't do
getting
that
faster
right.
and fast. You're getting
All right.
faster and faster. Well, maybe you are, maybe you.
There we go, right?
Actually, I'm seeing there we are. Finally, there it is. Okay.
Okay, all good.
Oh, good.
Sorry for the delay.
It's all right.
So I dropped part 9 of my series, The Magic of Tesla FSD, yesterday in the midst of all this crazy investor stuff going on, and I called it the Reasoning Edition. And it's funny. I write these things. I never expected to write more than one part, but everyone I think, oh, I have more to say. There's more. It's been revealed. I'm learning more about what they're doing at Tesla. And this one I feel like is the capstone to the thing,
Hmm.
but I bet it's not. I bet we keep going. I bet there's more things to say. But this one I think pulls it all together.
Okay.
I mean, at least as of now.
Right.
And so, the point of this is that um, before I jump in, Elon has said that, version 14 point, he first said version 14.2, he moved that to 14.3, will feel almost sentient.
Hmm. Yeah.
And I think, he's received sort of praise for that, a little bit of criticism as to, what is a sentient driving autonomy system feel like? What are its piece parts? What is reasoning? What is reasoning? It's a funny thing when we think about AI, because a lot of us who know the plumbing pieces of it realize that it's not magic, that we understand how it, functionally comes together. And I think a lot of us, including people who've worked in the space, are kind of amazed at how LMs actually do the thing that they do and make sense of themselves. How these insanely good word predictors literally can almost think.
Yeah. Oh, yeah. I'm using LLMs now probably 15 or more times a day,
Yeah.
because as I'm working, as I'm researching, I'm like, oh, now what has the average GDP gone up over the last 25 years? Oh,
Yeah.
and
It's
what years was it over 5%? I mean, those things would have taken me so long to
it's
get.
it's
And now it's like that.
it's absolutely extraordinary how much information how deep you can go on information research. in every topical area these days. Stuff that, yeah, I mean, when I was a kid, you would head off to the library and,
Yeah, right.
the cheat would be the encyclopedia,
Yeah, yeah, yeah,
right? That would be the cheat, right? That would be the topical
yeah.
text where you could find the body of knowledge of all things. Um, and then if you really needed to go deep, you would find the primary text that a lot of
Mhm.
things were written about. So, but I mean, now that's just at your fingertips, and that's extraordinary. And I think we're living in a pretty extraordinary time that this is true, that you can do this from your home. You can learn as much as a medical doctor, you can learn as much as a statistician, you can learn as much as a physicist,
Yeah.
by just asking good questions.
And not just from your home. Yesterday morning, I don't know how my brain started, going down this thing. I spend right now, my wife and I have gotten it up to a month a year we spend in Kauai in this condo that we love overlooking this amazing cliffside view. And I thought to myself, after she retires, I wonder if we could travel full time. So I said to Grok, what does it cost to travel full time? I started out, what does it
Yeah.
cost to be on a cruise full time? And it's like, 6 to 10,000 a month. What does it cost to travel full time, to stay in hotels at beachfront locations full time? About 6 to 10,000 a month. So I could, with what I do for a living, I could literally be traveling the world, staying on cruise ships or staying in beachfront hotels full time, operating my business.
Well, put it to work. We'll see. Yeah.
That's pretty good
Okay.
AI there.
Yeah. So, okay. So what we'll talk about is this, viewers can read this article online on my X account. I think it's pretty good. Like, I mean, I'm pretty pleased with it. I'm not always pleased with what I write. So I'm saying that not because I'm pushing it, but rather because I think I actually did a good job. So,
I was
so
pleased with what you wrote in the book, by the way. So, buy the book, buy the book, buy the book. Okay.
yeah, I'm actually pleased with that too. I spent a lot of time making sure I made sense there. I wrote the chapter on data. Um, and I tried to capture as much as I could about the state of data and AI today that I know of. And sure enough, I did ask Grok a few times, like, what am I missing in this chapter?
Yeah.
And it helped me along. Definitely helped me along. It said, oh, you haven't talked about, geopolitical stuff. You haven't talked about economics. And I'm like, yeah, the stuff I'm not interested in talk about. So, but it's in the chapter now.
Yeah.
So, I could put together a lot of slides, but I think we should focus on this one. Um, we've seen this before, but I kind of really built it up. And this is a way of talking through all of what's happening in the reasoning system in FSD. All right. Um, and I'd start by saying, well, what does it mean to be a reasoning system? And if you back out, the thing I'm not talking about today is this table stakes kind of reasoning, which you could say is reasoning, which is the idea that the car takes in data, goes through an AI, and outputs control values that drive the car safely from A to B. Now, that's obviously what we want our car to do. So, if you want to stop there and call that an amazing reasoning system, that's awesome. But I think there's more to come.
Well, the reasoning that already exists would, I suppose, be the planning through the maze of objects that
Yeah.
are potential,
Yeah.
could cause potential damage, as well as taking the correct route to get you to your destination appropriately.
Yeah, it's a very, very complex package of stuff that we're teasing out here today and adding to. But yeah, that evaluation phase that takes the raw data and converts it to action to drive the car safely to A to B and avoid every obstacle, which obviously is the definition of some part of the safety. Also, drive the car fluidly
Right.
in a way that feels human. Um, but I think more is coming, and so let's break it down by virtue of this particular uh, diagram here.
Mhm.
This is a logical diagram. Not everything is, this isn't exactly the architecture in the interior, and there's more boxes that could be revealed, but it's okay. So really what we have here is we have two AIs. So the setup is that we believe it's table stakes to do driving from A to B, and we're going to build on that. And we're going to say, what are the things necessary to build on that? So I think it's reasonable to say that there are two AIs in the system, an action AI and an interactivity AI.
Mhm.
Now, the interactivity AI, which I put in lighter gray, is not fully realized in the vehicle yet.
Right.
There are hints that it's coming, and certainly we'll talk about that. So let's walk from left to right through this and just tee it up.
Yep.
So this system, FSD, uses a neural network to process sensor data, sensor input data, and output control values that drive the car. So on the left, we characterize those very values. There's camera data, which is about over 90%, easily over 90% of the data that is input. So all the little light blue boxes are inputs to the system.
Mhm.
We have vehicle kinematics. That's the IMU, the GPS odometry. That's basically telling us, how the vehicle's acceleration, yaw, pitch, roll. GPS has given us positional accuracy. And then we have audio data, and we use audio data in the action portion to listen for the car listening for emergency sirens and so forth, and potentially eventually horns. Maybe they do that today, but I think mostly for emergency sirens. So the action AI is something we're quite familiar with, because what it's doing is taking the sensor data, which you characterized, and running it through this glorious kind of black box we'll call a neural net. It is a neural net. And then it's outputting control values, the little purple boxes. And really, we have three primary values. You could characterize it as two if you want. The steering out angle and acceleration, right? You could say braking is negative acceleration.
Mhm.
In other words, what's coming out of the system is saying, steer the car this way and apply this kind of acceleration. If it's a negative number, then the controls decide whether that's going to be what's effective for that is, can we, over the time period, the temporal window, can we use regenerative braking, or do we have to apply, actual brake? So that's the, little control box that decides what to do about that. So again, left side, we have inputs, right side, we have the outputs. Ashok Ghoswami, the VP of AI at Tesla, has characterized this as this system runs 36 times a second on your vehicle. He's characterized it as 2 billion input tokens and 2 output tokens, 36 times a second. Okay, that's quite amazing. 2 billion to 2. Yeah. The 2 are steering angle and acceleration. So what's interesting about this action AI, I'm sorry, we really have 2 more inputs to discuss. Routing, which is sort of the puppet master of the system. In a sense, it's the external system that, is giving the action AI a plan as to where to go on a much more macro scale. Like, in other words, it's not about the next 20 feet, but it's about, taking First Street to go left on Market to get to, so forth. And then we'll talk in a moment about the stuff about preferences, etc. In the action AI, normally, so Ashok Ghoswami had characterized it as end-to-end AI. Now, we should probably define that. There's sort of a formal kind of definition of end-to-end. Kind of what this is saying is that the data that's training the model flows all the way through the neural net of the model to set the values. It actually does that on the back propagation step. We'll leave all that out of this discussion. But end to end means that effectively we're training the entire model as kind of a monolithic thing, even though, even though that the interior is a bunch of little logic blocks that are principally a mixture of experts architecture. In other words, inside this box are these little things that know how to specifically drive highways, take exits, run through intersections, stop at intersections, manage parking gates, etc. But they're trained as a whole. Okay. And the problem with these end-to-end AIs is that they're kind of opaque. You know, like you get all these numbers inside, and then you have to ask yourself, like, you don't know what any given number inside the parameters means. You can't tell that. There's no way of really doing that. And you don't get a chance to see if you have a problem, did this module contribute to the problem, or did this piece continue to, it's very, very hard to debug it, debug the system. So what they did to start this process is that they output not just those control values for steering, angle, acceleration, braking, but they also output intermediate tokens they call reasoning tokens. And this gives us an insight into the why. The why is, or the why of why the system does what it does. So we can introspectively interact with the system, let's say as a Tesla engineer, and we can ask it, why did you do this? Why did you take a left-hand turn? Oh, that's because there was a detour sign or something. And you can see in Ashok's presentation that he shows literally a dialogue. They have part of that reasoning system is a small natural language system, which, you know, folks would think of as sort of like an LLM, maybe not a large language model, maybe a small language model. But the point is that they have started to lean in where they're making this thing have a great deal of interpretability. That's the word they use, meaning that you can sort of ask the black box, why did you do what you did? And it can tell you why it did what it did. Now, today, they're mostly using those reasoning tokens for the purpose of debugging the system. So problems are reported in the field, or they see problems in their simulator validation steps, and they can dig in and say, okay, what happened here? Why did it take a right on red when it's not supposed to at this stop intersection, et cetera. But these reasoning tokens will be very, very useful and used for the purpose of building an overall reasoning system. And then they will have two types of flows. They will flow downward to the interactivity AI, which we're about to talk about, and they will flow back in to the action AI itself. And in other words, they're sort of another input. You know, the action AI created a set, and then they kind of get recycled and thrown back through because it's creating context and it's giving us a temporal window of context. In other words, a time-based, we can say what happened 30 seconds ago. We know that because we've got a window of time at which we're creating that context. Okay.
So my biggest question so far is when you ask it a question like, why did you make that left turn back there? Is the system allowed to give you defensive answers, to gaslight, etc.?
I think the system would be no, I don't think so.
So this is an all-male channel.
Yeah.
Only men listen to this channel. So for the few women that are listening, you know what I'm talking about, and the men are going, Randy, you've gone to the other side. Anyway, that was kind of a try at humor.
It's a reasonable joke. I don't think it landed as well as you wanted it to, but yeah. So okay. It's a good try though, Randy.
Thank you.
I give you some, yeah. You know, when you go on that cruise ship, do not pretend that you can make extra money as the stand-up comedian on the cruise ship.
Oh, whoop,
You know, you might have to bartend or something, you know. So, okay. Another really important component to this whole reasoning mix is the interactivity AI. This is something that, in a sense, we're seeing a glimpse of with this ability for somebody at Tesla to get in there and debug the system. They're interacting with the live system. Remember, this is the live system that's happening in the car or in simulation or, I mean, validation within the data center. Interactivity AI is our ability to interact with the vehicle itself as a primary occupant or secondary occupant of the vehicle. We're going to call these folks occupants now because they're not drivers anymore,
Mhm.
right? And at some point, in robotaxi, they're not drivers at all. They're literally occupants, and they'll want to interact with the vehicle in a very natural form. And so the interactivity AI will provide essentially three things. It'll provide a speech to text AI so that we can speak naturally to the vehicle. On the output side, it'll have a text to speech so that the vehicle can speak naturally to us, speak back to us. And in the middle, it'll have sort of an LLM, essentially. Now, what is this thing? It could completely come from xAI's work. It can be a Grok Lite
Mhm.
because we'll want more in this model than a deep interoperability LLM for the vehicle itself. We'll want to have, world knowledge and other things so that you can speak to the car about potentially things outside the realm of driving itself.
Mhm. Mhm.
Um, Much like you could speak to Grok today and ask it general principle questions.
Right.
But let's just focus on what that does here for us. It provides a means for us to instruct the car on things we wish, actions we wish it to take, as well as preferences, meaning we'll consider them permanent actions, meaning actions we wish to instill in its reasoning architecture.
Mhm.
Uh, and I'm about to give an example, walk us through an example, but basically the input to interactivity is, of course, not just audio. As you can see, the audio channel comes into both the action AI and the interactivity AI because the audio, the capture of audio in this case is us talking to the vehicle,
Sure.
right? But also kind of a context window of all the preferences and previous context of our conversations flowing through the system, with some cap, but so we can do things and here and we can say, for example, we can interact with. I've used this example before, but it's a good one. Like, let's say I'm taking a robotaxi to the airport from South San Jose, where I live. I could say, what route are you taking? It says I'm taking 101. Now I don't like 101 because it's trafficy and garbagey and so forth. And I say, well, I'd rather you take the 280/380, which is the more scenic and comfortable. And the car could respond, that'll take another 7 minutes, and I'll say something like, "What time am I arriving?" And it'll come up with some number like two. Well, if we take the 101, it'll be 2:30. If we take 280, it'll be around 2:37. Oh, when's my flight? Is my oh well, your flight's already delayed an hour. Okay, well, I don't really care, so let's take 280. And maybe it will either infer from that conversation or ask me quite directly, when we go to the airport, do you always want to take 280 over 101? Which then becomes more of a preference, something
Mhm.
that kind of gets solidified. And it follows me around, not the car. That's
Right.
an important thing. It follows my Tesla account,
Mhm.
so that every time I get in a robotaxi, that piece of context about Phil's preferences is essentially inflated or comes about to be the
Right. Right.
preference. So what we have is we've talked about sort of this architecture of this thing, but we really haven't said, like, what are, beyond the example I said, what's happening in this reasoning architecture? What's happening in the reasoning architecture itself that provides the ability to do specialized things beyond just the driving package. So let me give you a good example, and it's already there. It's the ability for FSD 14.1.x to navigate parking gates. Um, Are you still with us, Randy?
I'm
You look
still,
like
I'm still
that's
with you.
okay.
Yes.
Your picture looked frozen, so I wanted to
Okay. Okay.
see if I lost connection there.
I'm good. I'm good.
Yeah. So let's talk about parking gates because I think it really will illustrate what's going on here. Um, Parking gates are complex. The reason we didn't see them in 13 is Tesla did not have this park to park. People are calling park to park. That's cool, but what really it means is that Tesla did not have this complex management of state within 13. 13 was go in, drive from A to B. Here we have a system that's starting to manage state transitions. So let me give you, it's essentially operating as a state machine. Now, if that's a confusing term, it won't be as I explain what's going on, because what happens is the car first approaches a gate, and it has to ascertain through its perception side whether that gate is a permanent gate or it's a gate that goes up and down, right?
Mm-hmm.
It doesn't have to understand why it goes up and down. It will bring us to the gate, and then it will pause and wait for the gate to open. Now, it has now entered a new state. It has gone from a driving state to a pause state, a waiting state, and involved in that waiting state is also a timeout, an ability to jump out of the state back to an error state. For example, it may wait for a certain period of time and the gate doesn't open. It realizes it's not going to open. Now, maybe through the interactivity AI that we're able to say, hey, this gate looks like it's broken. Please back out. But the car may do that on its own. So what's happened is it's gone into this waiting state. Now, it doesn't really care that what we, the occupant and or human driver, is doing. We could be fiddling with, we could be punching in a code because it's a private garage. We could be prepaying. We could be taking a ticket. We could be doing like any of those activities. And we could also be doing nothing. It could just license plate read the car and register it as either an allowed car in this restricted area, or just mark it as the time in for the purpose of payment on timeout. And you can also extend this example to the gate on the way out, right? Maybe that's where you have final payment, or it's just a license plate read. It's 2-hour free time. It's okay, but it's basically waiting for the gate. And when the gate opens, the car proceeds again. Now, what's happening? Inside this action AI, it's managing all this. But what it's not doing is it's not managing it with any human written code. And that's quite remarkable, because you would think, oh, I get it. It's gone from one state, the driving state, to approach the gate, obviously, to the waiting state. And someone's kind of glued these things together, these little things that, these little, we'll call it modules within the action AI, and said, oh, wait for 30 seconds or wait for 2 minutes. And if the gate doesn't open, then do this, go back to this state or proceed to the next state. But that's not what's happening. What's happening is the AI itself is managing a state machine through this temporal context of bringing information back. And it is in the interior, it has this what we call mixture of experts architecture. Now, I've talked about that, I think, in part 5. So if viewers want to get into that, I think they can go back to, it's part 5 or part 6, where I talk about mixture of experts. But think of this as experts are these little modules that sit within the action AI that do things like, I'm the guy that knows how to drive freeways very well. I'm the guy that knows how to manage intersections very well. I'm the guy that knows how to wait at gates very well, or wait at anything very well. And normally what happens in a mixture of experts, and the reason they call it mixture, so these little blocks, they're referred to as experts, and they call it mixture because they can all be active at the same time, but they have a sort of influence, a weighting. How active are they?
Mm-hmm.
So in the case of waiting for the gate to open, we may say that the waiting expert, it has 100% influence at this point.
Mm.
Everything else is just sort of dormant or blacked out. But on a highway drive, we might say that the highway expert is in charge at 80%, but since it's pouring rain, there's a weather expert that's involved, and his influence is 20%.
Mm-hmm.
And his influence is effectively slowing down the dynamics of the vehicle, right? Because of the inclement weather.
Right.
But the highway expert itself is saying, this is how we drive the highway safely. The weather expert is saying, this is how we do it in inclement weather. So altogether, the word that needs to be taken away here is state machine. It is to do these reasoning steps, to go from step one to step two. You effectively have this internal machinery that manage state from one step to another. And that is a good articulation of reasoning, because it's a logic flow that you and I as a human would do the same thing.
Right.
You know, so if we come out of that table stakes argument about what is reasoning, and we say, and we get into this higher order, we'd say that what has to happen here is that the action AI has to output these reasoning tokens to give the system a why, and that these reasoning tokens have to be played through the system, and the system has to build evaluation actions, if you will, based on its context, right? And then it can apply in user preferences to give it more nuanced control and interactivity with effectively the occupants of the vehicle. You and I would say that we reason with others often, right? And so that interactivity is a really key component of that. So if you pulled it all together, you might use an example that I use in the article, where I say, imagine that you approach a mall, and you've asked the car in a previous approach, whether it's robotaxi or your own personal vehicle operating autonomously, normally drop me off at entrance one.
Mm-hmm.
And when you've asked the car to be banished to parking, you've said, oh, by the way, park in the free parking lot and pick a corner spot if you can find one. But if it's, inclement weather, raining, snow, whatever, sleet, go use the paid parking garage. Mm-hmm. Right? So now you've got these preferences. Drop me off at this entrance. But in top of the preferences, you have weather inputs coming into the system as part of the reasoning. And then you might say, but if it's after 6 p.m., mm-hmm. drop me off at entrance 2, because that's where the restaurant movie section is of the mall. And that's your typical place. And the system can either ask you to remember that, or it can just remember that. And so you approach that mall at 7:30 at night with your wife or your spouse, and it automatically brings you to entrance 2, and then plays by the previous parking rules. Now you've got a system that's taking various inputs from every one of these boxes, every input box, and building a plan that satisfies your desired driving, plan. Mm-hmm. And so that's sort of a reasoning system. And you can imagine those things will get more complicated. So while we're at it, let's jump into more complicated.
Okay.
And let's add Optimus.
Uh-huh.
And I'm going to lean in a bit on Optimus in a minute, but I'm adding Optimus here. And what I'm saying is this reasoning inference for Optimus is the same thing. It's the same thing. There's some differences. I've put them in red squares. On input, We have touch sensors that can, on fingers of Optimus, it can detect shear and various other types of touch properties. But we still have cameras. We still have IMU. We likely have GPS. It should know where it is. But we certainly have the odometry. Well, we know it needs to know where it is.
Right.
We have audio because
Sure.
it too must perceive the world through its ear sensing component. And the middle part looks the same because it is the same. But now let's take a look at the right. The controls are a lot more involved. People would say that FSD is like 2 degrees of freedom, whereas Optimus is, 100 degrees of freedom, meaning you've got all the movements in the hand, the elbow, the shoulder, the legs, the torso, the neck, just like humans, articulate all those body parts through a set of actuators. So it's a lot more complicated output mechanism. So if you think of it as 2 billion input tokens instead of, the 2 output tokens, you might have 100 output tokens.
Right.
But it's the same AI.
Mm-hmm.
And now if you start to think about it, you say, well, wait a minute. What does that mean? I thought, Optimus is requires a lot more things in the middle. It has to do things like if I ask it to cook me an omelet,
Mm-hmm.
it needs to retrieve eggs from the refrigerator. It needs to retrieve some other things from the pantry. It needs to retrieve, a pan from some cabinet. It needs to break the eggs and cook the omelet. It needs to plate the omelet. It needs to clean up, potentially rinse the dishes, put them in the dishwasher. Well, guess what?
It needs an expert to get the what do you call it, the recipe.
Yep. Well, I mean, it needs to have a contextual input of the recipe.
Right.
But guess what? It's just a set of skills that are chained together through a state machine.
Mm-hmm. Mm-hmm.
So it's just the gate problem on steroids.
Mm-hmm. Mm-hmm.
Because now what we have is a problem where we have hundreds of little skills or experts, mixture of experts,
Mm-hmm.
that are chained together through this magical box of neural network, and that are weighted in a particular way that and can over a temporal period, meaning a time-based period, can take its reasoning tokens and send it back through and transition from one state to the other. So at some large level, you might say, well, we're done with the cooking state. We're moving to the plating state. We're done with the pre-cooking state. Now that's a zoom out on much smaller. There's much more smaller granular things
Sure.
that are going on inside there. But I claim it's the same thing.
Yeah. State to state.
Yeah.
Make a decision.
Yeah.
Reason through whatever it is that has to be. Find the expert if you need an expert.
Yep.
And all of this is happening multiple times a second.
Yeah. And what should be extraordinary about or reveal if someone says, oh wow, that's a bit of a revelation to me that these things are the same. I have a slide here where I talk about this. By the way, part 8 of my series we talked about on the show, I think 2 weeks ago or something. I talk about Magic of FSD Optimus Edition, where I'm literally talking about these convergent architectures, that they share this foundational vision architecture and all the stuff in the middle of what Tesla has done,
Mm-hmm.
and that it is effectively a unified architecture, and that right now I think we think perhaps the big daddy, the big dog is FSD, and Optimus is the project in the corner that's getting some love from the team for doing its AI, from the things that that have come from FSD. But I claim, and by the way, this is one team. It's the AI team. They're doing both projects concurrently. Uh, but I claim that it will swap around pretty quickly, and that Optimus will be the big daddy of the projects, and the 2 degree freedom driving problem will seem small compared to the Optimus problem. But here's the thing: recognize this, and maybe this is the big thing. Uh, while you first perceive that these are very different beasts, they're not. They take the same inputs. They have a set of actuator outputs. Their interior AI systems are the same. Um, what you would think is, Optimus has all these little, sub skills, but it's the same. It's the same. It's just much more granular. I mean, much more granular. Um, but here's the cool thing. I mean, maybe this is the lift. This is the thing. What will end up in FSD as a driving system will be so far beyond what others approaching any type of vehicle autonomy will look like, because it will really truly be a reasoning system. And that will be brought to you by virtue of what has to happen in Optimus. So what I'm saying is, if you bought an Optimus for the home,
Mm-hmm.
I don't think they'll start in the home. I think they'll start in manufacturing, where some of these things can be dialed back, um, move into maybe service where they start to interact with humans on a more regular basis, service industry, making your coffee. Maybe at first they're cleaning the restaurants. Later, they're waiting on people. But eventually, when they get in the home, they're a very interactive device. And the expectations for the device are very high.
We need it
Very
to be,
high.
we need it to be just like Hal, or even better than
Yeah.
Hal.
Yeah. I mean, we would expect to be able to interact, have it talk back, uh, not that kind of talk back, but talk back to
Maybe
us.
that too. That's it.
Yeah, maybe talk back to us.
Yeah.
But seriously, we would expect it to do um, a lot of very intricate, skilled things like cooking. Cooking's a complex thing.
Mhm.
Even cleaning is a complex thing. When you break it down, you think about what's going on. We think about it to be very horizontal in its application through the home, and so it should be able to do almost anything we ask it to do, and it should be able to eventually learn to do things that it wouldn't necessarily be trained on
Mhm. Mhm.
out of the gate. Um, and so we would have a high degree of expectation of its reasoning capabilities, and that's cool because push all that same architecture back onto FSD as it matures, and we realize that FSD manifests the same level of intelligence, reasoning, appearance of sentience that Elon mentions. And so that's the upshot of this.
Yeah, so as I'm listening and watching the various videos and people that are making comments about, 14.1.4 and 5, and some people are saying, talking about sentience. It seems to me, again, using one of the more famous male female, subsets of skills, and women tend to have this thing called intuition. When I talk to my wife about intuition, she says intuition really is a matter of observation. So women are more likely to observe your facial, what you're doing with your face. In other words, your body language that's in your face and your hands and the way that you're sitting, et cetera, like an FBI agent might do. So women are paying more attention to that kind of stuff, where guys are paying less attention. And so, even though it seems like it's sentient, seems like another level of sentience, where how can women, they have an eye in the back of their head when the kids are playing. No, it's a higher level of observation in those areas. And so this becomes the philosophical question on a robot is is there any level of where it really is sentience, or is it just higher skill sets being able to use its 8 eyes or 9 eyes or whatever it's got now, use better better microphone systems, and then, as was pointed out on the ATF, I'm sorry, Peter Diamandis's channel last night, as they were pointing out, it also does it so much faster. And as humans, we think of intelligence and sentience as something that's happening very rapidly. And
Yeah.
if you're able to solve a math problem in your head while somebody else is sitting there going, and having to write it down, you have a higher degree of intelligence.
Yeah.
So these kinds of things, philosophically, as we, over the next couple of 3 years, probably we'll be having this conversation a lot more, is will it ever, if it's numbers, to your point, if it's just numbers, will it ever truly be sentient, or will it just be a really fast reasoning machine who has superhuman
Yeah. Yeah.
ability to
Yeah.
see and hear? Yeah, yeah, yeah.
Yeah, it's a great question, and I'm not trying to approach this from a human cognitive comparison.
Yeah, yeah,
I think it's no, I think it's important to recognize that what we're talking about is the perceptions of sentience. We're not necessarily saying
yeah,
it has this kind of thing that we are still confused about, like a human consciousness.
yeah.
What is consciousness, and when does it when does it when does it boot up in the human,
Right.
and does it last until we die, or does it go on after we die? The human body, kind of is the human body necessary? All these philosophical questions are something that I think we can dial back on and say that these systems are not that system, at least not yet.
Not yet. Yeah, yeah.
Yeah, and I don't really need I don't need to think about that. Like I don't
Mhm,
I,
mhm.
I think of a reasoning system does not need all those definitional aspects.
Yeah,
Um, I think maybe the word sentient is an important thing where you might need some of those aspects, but in the paper I talk about the perception of
right,
sentience, not necessarily the actual
right.
actuality of it, because I can't even define it. All
Exactly.
right.
Nobody has yet.
Yeah. So I think what we're talking about is just leaning further and further into this is why I said im- so inputs are important.
Mhm.
Those inputs are those reasoning tokens are an expression of the why the box is doing the thing it's doing, which is super important to the reasoning equation.
Right.
The ability to manage state is super important to the observation that it can be a reasoning system, that it can work through states. You have to manage states, you have to work through states. The idea that it's interacting with you gives it a higher level of intelligence and from your perception.
Mhm,
We think of we often think of these things as like today we think of when you manage FSD, you say, okay, I'm going to put it in chill mode or standard mode or Mad Max mode, and these are modes, and within these modes are potentially maybe 100 little parameters that like Mad Max is like, here's the minimum vehicle offset to front vehicle, rear vehicle. Here's the minimum lane change requirements in terms of vehicles on our hip um, and all those. Now imagine that. So Tesla will never express all of those things as preferences in user interfaces because they will not need to. They will talk to us and we will tell the car. And it may operate in effectively Mad Max mode for a piece of a highway, but not another piece.
yeah,
So for example, we might say, don't exceed 79 miles an hour anywhere on the 280 northbound between
mhm,
San Jose and San Francisco, because we know that the police are there at 80 miles an hour. That they're willing to give you a ticket, but not at 79.
sure.
By the way, which is true.
Yeah,
um, so we may tell the car, just whatever you do, don't exceed 79 miles an hour. I don't need the car, I don't need that kind of situation. But then you'd expect the car, just through all the other aspects of its perception, to start to be able to do something that's way beyond that box. Way beyond that box is Well, why don't you build up a database of every single time you see a car pulled over on a highway segment and see what the density of, now you may not know why the car is pulled over. It may not be a speeding thing. You don't necessarily know the reasons, but you can, if the cars recorded that, if the cars in aggregate communicated out, in other words, consider it another piece of data on the maps.
Yeah.
You
Yeah.
know, consider.
In a future world, I don't think in the current world, but you talk about this interconnectivity and whatnot. In a future world, the certainly the LLM aspect or feature has the ability to go out and ask the question of the universe, when did the police pull people over in terms of speed?
Yeah,
And have it come back and say, oh, 79 miles an hour is the best you can do on a 70-mile zone.
yeah,
And
yeah, yeah.
so there could be that interactivity with the world of knowledge as well. Now that would start to feel like,
Well, I mean, isn't that what we're doing?
yeah,
Isn't that what
yeah,
we're
that's
doing?
what we do.
We're
Yeah,
if we tell our car we have a preference to drive
yeah,
79 miles an hour on that stretch of highway, we've
yeah,
already done that research. We don't know
yeah,
how. We may not be able to articulate it, but we've talked to friends, we've
right.
talked to
Yeah.
CHP officers in the area, we've talked, we've gotten our own tickets or whatever the case may be.
Mhm.
Um, so yeah, I mean, it's the ability to do, I think one of the things that is startling about these systems and the reason that they appear so intelligent is at the speed at which they can do things.
Mhm.
You just said before, it's like if someone were to do uh, I had a roommate in college who was genius level in my opinion, and he could take any, I could say seven times nine is 63. I hope it is. Um, but he can do 79 times 64 and answer it exactly at the same speed that I could do two digit. He
One
could
digit.
do two by he couldn't do three by three, but he could do two by two. And he could do it at the same speed I could do the one by one.
Mhm. Mhm.
And so I always said, wow, John's a really intelligent guy. And he is, by the way. So but if a robot does that with a four by four or a 10 by 10, is it more intelligent than John? That's one aspect of
Yeah,
intelligence.
no,
And there,
it's really also goes back. We talk about a lot this in the book a lot. It really goes down to another thing that people kind of forget. I will admit I had kind of forgotten it until it was made clear to me watching this particular podcast, and it was when we created fire, we extended the human to another level, to a superhuman level,
you know,
because I can't warm up my pan with my body heat.
yeah, right.
If I want to warm up that pan, I needed to invent or find or take advantage of fire, which levered me up
Yeah.
into another level of superhuman capability. So when we invented the wheel, et cetera, et cetera, et cetera, it's always moving us up and levering
Yeah.
us into a superhuman level. Well, all this new stuff levers us up again into
Yeah.
levels
It's
of
yeah,
superhuman.
that's great. That's a great way of saying it. It's like even, you imagine candlelight in the 1700s and all of a sudden people could read in the evenings where they would typically just go to bed, when it got dark, and now through fire, through candle, and then eventually electric light. Now you could read. Well, then guess what? As if you could ingest the content of reading material in the evening hours, you became more intelligent. So you had this tool that levered you up.
Mhm.
And we'll see the same thing. We're seeing the same thing. I mean, I feel as though I have much more knowledge now that I can interact with an LM on. I mean, I research all sorts of little things. I've always been super curious about, like, I'll say something and then I'll think, wait a minute, why do I know that? Is that really true? And I've always wanted to look it up. And uh, when I was a kid, that was a harder act.
Yeah.
I couldn't jump those states that quick. And now, and a couple of years ago, it was all internet. You could just go on the internet and then you have to kind of parse stuff. Now you can talk to an LM and you can say, uh, you know, give me the answer to something fairly complex, which can then allow you to learn something and instill it in your brain and your future cognitive capability. So yeah, I mean, our interaction with these systems, um, any of these autonomous systems will be glorious tools, you know. So
Well, Phil, listen, you are always an extremely fun person to talk to about these issues, but I'm not sure that you have the gravitas to hold on to people for an hour and a half or 2 hours like some of the other podcasts.
oh,
So,
okay.
I think we're going to have to cut this one off.
That's fine. I just did that take gravitas? I don't know what.
Well, I'll listen to an hour and a half of All In, or I'll listen to 3 hours
Yeah,
of Lex Friedman. Joe Rogan. How long was he with Elon the other day?
three
You
and
know,
a half hours.
yeah, but you and I don't think that people are going to listen to us for
No, they're
3 hours.
not.
Maybe. I mean, who knows? But
Nope.
right now, I think we're stretching their patience. We'll see what
Yeah,
we'll
yeah.
see what happens in the comments below. So, so as always, Phil, so great to have you on and
Right. Cool.
filling us in on those aspects. And to all of you out there, it's been buy the book, buy the book, buy the book. And to all of you out there, it's been great talking to you.